Okay. Good evening. Our problem for this evening will be evaluation of integrals. Okay, I will try to give you the problem. We are asked to evaluate the integral of sine of theta, cosine square of theta, differential theta, all over the square root of 1 plus cosine of theta. The given integral problem is in terms of trigonometric function. Okay, and the problem is asking that we should evaluate the integral. The solution I will be presenting will be solution by algebraic substitution. So the solution by using algebraic substitution, algebraic. The given equation is actually in terms of trigonometry, but I will be presenting an algebraic solution. Okay, so by using algebraic substitution, I will let z equal to the square root of 1 plus cosine of theta. Meaning this portion of the integral, I will represent that as z. Okay, that is our algebraic substitution. Z is a variable, it's not a trigo function, it is algebraic. That's why the solution is algebraic substitution. So if I will let this square root to be equal to z, okay, z will be equal to this, right? Squaring both sides, the square of z will be c squared, and the square root of 1 plus cosine of theta to the second power, the radical side will disappear, so it will now just be simply 1 plus cosine of theta. Solving for cosine of theta, solving for this, I will place it on the left, so cosine of theta will be z squared. I will transpose this to the left, then I will rearrange, so it will become z squared minus 1. Meaning cosine of theta will be z squared minus 1. We just rearrange, right? So we are now given cosine of theta as a function of an algebraic function. Okay, squaring both sides. The square of cosine of theta will be cosine square of theta, and the square of the right hand side, it will just be simply like this, right? We are free to do that. Cosine of theta to the second power will be cosine square of theta, and z square minus 1 to the second power. It's actually a binomial, right? We just square it. So it will be the square of the first one, which is z to the fourth. The middle term will be minus z square times 2. So this should be negative 2z square. That's the middle term. And the last part is the square of negative 1. And the negative 1 square is actually positive 1. So meaning cosine square of theta after the squaring is z to the fourth minus 2z square plus 1. Okay? Later on, we need this equation in the solution plus this one. That's why I mark this with the orange thing. So when we go back, we could see it immediately. From the equation cosine of theta equal to z square minus 1. Okay, this was originally without the square, right? So this one emanates from this. So cosine of theta will be z square minus 1. Differentiating both sides, or taking the differential of both sides. Theta is variable, z is variable, okay? Take the differential of both sides. The differential of cosine is negative sine, so it will be negative sine of theta times its differential theta equal to the differential of 2 or z square is actually, it falls under the power formula. So it will be 2 times z decreased in power by 1 times dz. This is actually minus 0 because the differential of 1 is actually 0, or this is nothing, right? This is a negative sine of theta, differential theta equal to 2z dz. And if we try to remove this negative sign here, we will multiply all terms by negative 1. So a negative sine of theta, differential theta times negative 1, a negative and a negative, this will now be plus sine of theta, differential theta, equal to 2z dz times negative 1 will be negative 2z dz. I will mark this with an orange thing, then I will check this one. We needed these three equations with a check mark to put it on the original integral to bring out the algebraic solution. So substituting, I will rewrite the hold on. I will rewrite the given integral. Okay, I will just rearrange. I will write first cosine square of theta. Then take the product of sine of theta differential theta as one quantity. And the bottom portion, the square root of 1 plus cosine of theta. Okay? I rewrite it like this because I now have the equivalent of cosine square, sine of theta differential theta, and this one in terms of the algebraic function. And cosine square of theta is actually this one. C to the fourth minus 2z square plus 1 close quantity. And the value of sine of theta differential theta is actually negative 2z dz. So this is multiplied by minus 2z dz. All over. That given square root, we represent that as z. Originally, our original algebraic substitution. This is all over z. So this here cancel with this. We could cancel out because the operation on the numerator and denominator is actually multiplication. So actually we could cancel out. But just in case there is a plus or a minus sign here, we could not cancel. Since the operation on the numerator is multiplication, we can cancel z and z. Okay? There's a common factor negative 2. We bring it out. The integral. The first one, it does not change. It will just be simply c to the 4 minus 2z squared plus 1 close quantity times dz. This dz here, it's this here, this negative 2, we bring it out. So after the substitution, okay, the resulting integration is now simpler. This is now in terms of an algebraic function. Okay? Algebraic, that's why the solution is algebraic substitution, meaning after the substitution, what will come out will be an algebraic function and the integration will be much more simpler now. So integrating the right hand side, no problem, it's all power formula. This is negative 2, open bracket, z to the 5 over 5, power formula, minus 2, c cube over 3 or minus 2/3, z to the third power. The integral of dz will just be simply close bracket. And if we try to simplify this one, okay, we will place back the value z equal to, the value z is actually 1 plus cosine of theta to the 1/2. To the 1/2 or square root. So meaning to bring out the final answer in terms the original function theta, we will place z as all equivalent to 1 plus cosine of theta to the 1/2. So I will now try to simplify this one. I will multiply first this minus 2 times the first one, so this should be, the coefficient will be negative 2 over 5. We will replace z by the value 1 plus cosine of theta to the 1/2. So this is 1 plus cosine of theta to the 1/2. Okay, raise that again to the 5th power. Okay. A minus 2 times the minus 2 will be plus 4. So this is now 4/3 times the value z, which is 1 plus cosine of theta raised to the 1/2. Raise that again to the 3rd power. I'm following this. Okay. The last part will be minus 2 times z. So this is minus 2 times the value of z, which is 1 plus cosine of theta raised to the 1/2. Indefinite integral, this is plus c. So simplifying this one, this will now be minus 2 over 5. 1 plus cosine of theta raised to 1/2 times 5. Laws of exponent, algebra, 5/2. Plus 4/3. 1 plus cosine of theta, 1/2. Again, raise that again to the 3rd power, that will be 3/2. Because in 1/2 times 3 will be 3/2. This is to the 3/2. Minus 2. 1 plus cosine to theta to the 1/2 is actually 2 the square root of 1 plus cosine of theta plus c. So this will be our final answer. Okay? That is a solution by using algebraic substitution. Okay? We represent this one as Z. Process this one. What will come out will be cosine square theta. We can compute for sine of theta differential theta. So we needed this 3. We put it back. After the substitution, what comes out is now an algebraic integration. And it now all falls under the power formula. And after the simplification, the final answer will be negative 2 over 5, 1 plus cosine theta raised to the 5 halves, plus 4 thirds, 1 plus cosine of theta to the 3 halves, minus 2 the square root of 1 plus cosine of theta plus c. That's it. That is an example problem of the evaluation of integrals by using algebraic substitution. Good evening from Los Angeles.